We have a request to do a fall 2020 nomenclature question. COVID semester. We gotta name this bicyclo. One of these must be carbon number 1. Those are the bridge heads. Okay. Interesting. They both have a group on them. So regardless of which one you choose to have be carbon number 1, you're going to have a group on 1 and then a group on 8. And those are the only 2 groups. And that's the rule that I say, I'm not going to teach you the rule that says which of those 2 groups is going to have to have a lower number. Because when I did teach that rule, they thought that rule was more important than having the lowest rule for the first group, and they would use that instead, forgetting that this is only if there's an exact tie for numbering groups, exactly, all the way around both ways. If there was any distinction between the numbers going both ways, then you got to use the first rule, lowest number wins. You want to go on the one on the bottom. And then you got to go 2 there. And you're going to go 7 here and 8 here. 3, 4, 5, 6, 7, 8. Good. And this group on 1, you've got to use the systematic naming. Somebody's going to say, I'm just going to call it ISO. You can. You can do that. It's got the ISO pattern. But you also have to tell me there's another methyl group on carbon number 1, 2, 3, 4, 5. And notice I started here because that's carbon 1 in the group. So you can call it 5-methyl iso 1, 2, 3, 4, 5, 6, 7, 8, 9 isononyl, or 5,7-dimethyl octyl. You want to see both names? Sure. I'm just going to circle the groups because I'm naming the group. You can call it a 5,7-dimethyl octyl group, and it's you need parentheses, right? And you want to see the numbers for that? And baby blue, that has to be carbon 1 in the group. Or you can call it a 5-methyl isononyl group. Verify both names give the same number of carbons. That's one way to figure out if you did something wrong. If the names give different numbers of carbons, then they're wrong. 2 methyls is 2, 8 is 10. 1 methyl is 1, and 9 is 10. Good. They're both acceptable names. This one starts alphabetic. They both start alphabetically with M, which will be after F. This is a 2-carbon group. What are 2 carbon groups called? Ethyl. I'm circling this group. And carbon number 1 in the group is this one. So there's only one acceptable name for this, and it starts with parentheses 222. It's a tongue twister, isn't it? 222 trifluoral. Ethyl. Small group with a big name. 222 trifluoral ethyl. You got to tell me where those florals are. So that goes by F, as in Francis. That'll go first. And you said that's on carbon 8. So here's your final answer. 8 dash 222 trifluoroethyl. And on carbon, let's be consistent. Black parenthesis. And very sensitive screen today. And on carbon 1, there's that other group. I'll go with a shorter name. 5-methyl isononyl. And then we're going to go with bicyclo. And what are the numbers? Between 1 and 8, without counting 1 and 8, a bridge size 6. I believe to the left it's a bridge size 5. And in the middle it's a 4. Careful. Wait, it might be a 3. 1, 2. You're correct. Sorry about that. I don't know why I thought that might be a 4. It's a 3. And 6 plus 5 plus 3 is 14 plus 2 is 16, correct? Hexadec. And right now you got half credit. I told you nomenclature's brutal. It's 1.5 out of 3. Maybe it's a 4-pointer and it's 1.5 out of 4. I don't even know. What's it say? Oh, it's 4. So you got 2.5 out of 4. I apologize. Because stereo centers are worth how much each? 0.75. So we still have 1.5 points to go. 2 stereo centers should be treated like 2 separate problems. Stereo center on carbon number 1 in red. We've got oh wow, we got a 4-way tie of CH2s. What a nightmare. How come I like the 1, 2, 3, 4, then branch? 1, 2, 3, then branch. I like this, and then I like this. CH2 once, twice, 3 times, then a C with nothing but C. CH2 once, twice, 3 times, then a C with only 1 bond to C. Right? CH2 once, twice, 3 times, then a C with only 1 bond to C. So why did I like? Oh, I don't know if I like 2. I had a, so 1, 2, 3, 4. The 5th one's branched. 1, 2, 3, 4. The 5th one's not branched. That's why. It's just CH2 up there. And the 4 must be the wedge, and I love when the 4 is a wedge. It's got 6 CH2s. The 4 doesn't look so good though. Yeah, the wrong answer is R, so the right answer is S. So 1 is S. 1 is S. Start all over for the other stereo center in green. A C that goes to a C. Oh, that's green on top of green. I'm not happy. Orange. A C that goes to a C with fluorine is number 1. A C that hits a branch on the 4th carbon is 2. A C that hits a branch on the 6th carbon is 3. And on the 8th carbon, 7th carbon, 8th, I don't know, 4. Let's make sure. CH2 6 times, CH2 5 times, good. And this one's all set up, isn't it? 4's on a dash already. Counterclockwise says S. So 8 is S in orange. A good one. It's a lot of work. I agree 100%.
That's why you do that.
You do it last for dessert. Yeah. Yeah.
Isn't there a third one?
Oh. Oh. Share screen. Just as a hi. Oh, no. Okay. It was correctly pointed out, our group has a stereo center in it down here, and I didn't account for that. I would have lost 3/4 of a point on my own question. Oh. Okay, what I'm going to do is extend this parenthesis backwards a little bit because it's got a stereo center in this group. And I think this is our easiest stereo center, I hope. That's one reason it's easy. 4, methyl 3. CH2 that goes to a branch is 1. The CH2 that goes to a non-branch is 2. And 1, 2, 3 is R. So you tell me that in the group it's an R stereo center. I'm sure glad she caught that before I quit the video. Yeah, that's a stereo center. When it's in a group, you do that. Now my computer's going to pretend it's going to crash. All right, see if I can get away with it.